Sound is literally all around us. It's in the music you stream, the notifications on your phone, and yeah, even the sound of my voice right now. But have you ever really stopped to think about what sound is? We're going to break down the science behind this incredible, invisible force.
So seriously, what is it? Is it a thing? Some kind of energy? Well, let's dive in and figure that out.
All right, so the secret behind every single sound you've ever heard, from the quietest whisper to the loudest explosion, all starts with one simple thing, a vibration.
Yep, that's it. Sound is pure energy. When you clap your hands or a guitar string gets plucked, you're making something move back and forth really, really fast. And that rapid movement creates these invisible waves of energy that travel outward, kind of like the ripples you see when you drop a stone in a pond.
But here's the catch. Those waves need something to travel through. They need a medium, like air or water or even a solid object. The sound wave is basically this chain reaction of molecules bumping into the ones next to them. And that's exactly why in the total vacuum of space, it is completely silent. No molecules to bump into means no sound, period.
So as a sound wave moves through the air, it creates this really cool repeating pattern. You get these areas called compressions, where the air molecules are all squeezed together under high pressure, and those are followed by rarefactions, where the molecules get to spread out in low pressure. It's this constant push and pull that actually propels the sound forward.
Now, hidden inside that wave pattern is a kind of code, a code that our brain is an expert at cracking. And the two most important parts of that code are what we call pitch and volume. They're what make a tiny bird's chirp sound totally different from a huge foghorn.
So the first part of that code is frequency. This is just a fancy way of saying how fast the original object is vibrating. We measure it by counting how many full back-and-forth vibrations happen in just 1 second, and the unit we use for that is called Hertz.
Now, what's really interesting is that we can't hear all the frequencies out there. The typical human ear can pick up sounds from a deep, low rumble at 20 Hertz all the way up to a super high-pitched whine at 20,000 Hertz. And fun fact, that range actually gets smaller as we get older.
And this is the key part. Our brain takes that raw data, the frequency, and it translates it into something we can actually experience. And that experience, that perception, is what we call pitch.
The connection is really straightforward. A high frequency, meaning super fast vibrations, is heard by our brain as a high pitch, like a whistle. And a low frequency, with slow vibrations, is heard as a low pitch, like a big bass drum. Simple as that. All right, so if frequency is about speed, the other part of the sound code, amplitude, is all about power. It's the measurement of how much energy is being carried in that sound wave. The more energy, the higher the amplitude.
We measure the loudness that comes from that energy in something called decibels. So a normal conversation might be around 60 decibels, but a rock concert, that can hit you with over 120 decibels. And at that level, it's not just loud, it's actually physically painful and can cause serious, permanent damage to your hearing.
Okay, so we have these invisible energy waves flying through the air, carrying all this information. But how in the world do they become the sounds we actually recognize? Well, for that, we have to take a look inside the incredible machine that is the human ear.
It's this amazing little process. First, the shape of your outer ear is perfect for funneling those sound waves down to your eardrum, making it vibrate. Then, those vibrations get amplified by the 3 smallest bones in your entire body. And finally, they reach this snail-shaped part called the cochlea, where tiny little hairs turn those physical vibrations into electrical signals that your brain can finally understand.
Okay, now that we've got the basics down, let's get into some of the really cool tricks that sound can pull off out in the real world, like echoes and its mind-blowing speed.
You've all heard an echo, right? Well, it's actually super simple. It's just a sound wave that's hit a hard, flat surface, like a cliff face or the wall of an empty gym, and bounced right back to you, like a ball bouncing off a wall. In a room with carpets and curtains, that sound energy gets absorbed. But with hard surfaces, it has nowhere to go but back. And this isn't just some cool trick. We've actually learned how to use echoes to do some incredible things. Ships use sonar by sending sound waves down and listening to the echoes to map the ocean floor. Bats use echolocation to see in total darkness. And doctors use ultrasound to look inside the human body, all by reading echoes. In the air around us, sound travels at about 767 miles per hour. That is so fast that when a fighter jet breaks that speed barrier, it creates a massive shockwave that we hear on the ground as a sonic boom. But here's the thing, sound speed changes. In water, where the molecules are packed way closer together, it travels more than 4 times faster.
This actually explains a classic question I'm sure you've all wondered about. The lightning and the thunder are created at the exact same moment, so why do we see one first? The answer is simple. Light is a speed demon. It travels almost 1,000,000 times faster than sound does. So the light from the lightning reaches your eyes almost instantly, while the sound wave of the thunder has to take its sweet time traveling through the air to get to your ears.
Okay, for this last part, let's talk about how we've learned to capture this invisible energy. And this is really important. We need to talk about why it is so critical that we protect our amazing ability to hear it. Think about it. A digital recording is basically an artificial ear. A microphone has a part that vibrates from sound waves, just like your eardrum. That vibration gets turned into an electrical signal, and a computer then converts that signal into a digital code, a bunch of ones and zeros. To play it back, your phone or computer just reads the code and tells the speaker exactly how to vibrate to recreate that original sound perfectly.
And this brings us to something that is absolutely crucial to understand. This whole system inside our ears is incredibly delicate. Those tiny little hairs in your cochlea that sense the vibrations can be destroyed by noises that are too loud. And unlike a cut on your skin, they do not grow back. Once they're gone, they are gone forever. Now the good news is protecting your hearing is actually pretty easy to do. Keep the volume on your headphones low enough that you could still hear someone talking to you. If you're going to be around really loud noises like a concert or fireworks, wear earplugs and just give your ears a break sometimes. Find a quiet place and let them rest. So, after going through the whole incredible journey that sound takes, from a simple vibration all the way to a thought in your brain, I have a question for you. What's one simple change you can make, starting today, to make sure you protect your hearing and can keep enjoying the amazing world of sound for years and years to come?